Welcome to Chapter 10. So in Chapter 10, we're going to talk about correlation and regression. In this video, we're just going to focus on the correlation part of that. So when we're talking about correlation or regression, we're talking about data points that have two variables, and we plot them on an x and a y axis. So whatever our first data set is, that's normally along our x-axis, and our second data set goes along our y-axis. And so we plot them just like you would plot points in other classes. So correlation exists between two variables when the values of one variable are somehow associated to the values of another variable. So they could both go up at the same time. They could both go down at the same time. So just they correlate if there's some association. So we say it has a positive correlation is when we look at the data points, if overall they're going like a positive straight line. So you can think of a positive slope. And we would say, and so here we're saying as one variable goes up, as it goes up this way, the other one also goes up. So they're making this positive slope straight line. Negative correlation would be if they make generally a line with a negative slope. Okay. Now here we're saying when the x variable goes up, the y variable goes down. And no correlation would be if they were truly just scattered all over the place. Maybe they're in lumps, but there's not kind of a straight line that goes through them well, either positive or negative slope. So here's some things that we can talk about when we're talking about correlation. So the linear correlation coefficient R is going to be a number we have for a data set here that measures the strength of the linear correlation between the x and the y values of the sample. So it's just going to tell us how strong that correlation is. And the R value will always be between -1 and +1. If it's negative, it will have more of a negative slope, and positive, it'll have a positive slope. And the closer to positive or -1, the more closely it correlated it is. Okay? So we'll choose a significance value, and we'll decide if there is linear correlation. Now the table we need is on our formula sheet. So I'm going to pause that and pull it up. Okay, so here's our formula sheet, and for the first time, we'll be using the values on the second page. This is the table we're going to use to help us decide if there is correlation. So if R is negative, the number, we'll get R from our calculator. If it's negative, then there's linear correlation if the absolute value, so we'll look at, we'll ignore the negative, is bigger than the critical value, is bigger than the number we get off of the chart. So these values are our critical values. And if R is positive, then we just look at R and we want to know if it's greater than the critical value. Now, one thing to know is that our R value is very sensitive to outliers. So if you have a data set where one is just very far from the others, it will affect R quite a bit. Okay, you may sometimes see the value R squared talked about, and R squared describes the proportion and variation in Y that is explained by the linear relationship between X and Y. So R squared just describes the proportion of how these two are related. And something that's always important to remember, just because there is correlation, if we decide statistically there is correlation, that does not mean that there's causation. It does not mean that one variable is causing the other one. It could be that you just kind of got lucky and found two things that both go up or go down at the same time. Or it could be that there's a third confounding variable. So kind of a famous example, you can say that the temperature during the day and the number of murders that happen are correlated. I meant to say the number of ice cream sales and murders are correlated. So as ice cream sales go up, so do the number of murders that happen. Well, both of those tend to go up in the summer. So it's not that ice cream sales are causing murders. It's just that they both tend to rise around the same time of the year. Okay, so to find the linear correlation of your data set on your calculator, you're going to turn on your calculator. Okay, now this is telling us to clear out y1. So if you go to y equals, you just don't want anything in there, which you can just hit clear and it'll clear it out. So we're going to turn on plot 1. So this plot, we're just going to go up to it and hit enter. Okay, and it says turn on your diagnostics. Now you'll only have to do this once. So you're going to hit second catalog, and we want to go down to where it says diagnostics on, which if you hit the button that has the D above it, it'll go down. Okay, so here where it says diagnostics on, you're just going to hit enter, enter. You don't have to do that for every problem. Unless your calculator resets, it'll be good. Okay, now we're going to put our data into L1 and L2. So I'm going to pause. Well, we'll do this when we get to the next page. Then to see the scatter plot, you can hit zoom 9, and I'll show you how to do that. And I'll also show you how we can calculate the linear regression. Okay, so we're going to look for ln reg A plus BX. So this is the data set we're going to work with. So it says, as the circumference of trees trunks increase for a certain species, can we expect the trees to be taller? So if they get wider around, do they also get taller? So it says, in other words, is there significant linear correlation between the circumference of a tree's trunk and the tree's height? So I'm going to pause this and I'm going to put these values in L1 and these values in L2. Okay, so I've put these values into L1 and L2. And if I hit graph, we may not see anything right away. If we hit zoom and go down to where it says zoom stat, it'll make a nice scatter plot for us. Now we can also do that by hand. So this would be 0, 0, and I'm going to label these by 1s. And we could label these by 10s. Okay, so we'll do the first one. So we have 2.4 and then 40.7. So we'd go to about where 2.4 is and then go up to where 40.7 is and put a dot. Okay, for the next one, so we'd go 3.1, so just past 3. Oh, it erased that last one. Okay, so 3.1 and up to 24. So we'd put a dot there. Now I'm going to pause this and fill the rest of it. Okay, so I filled in our scatter plot, and we can see that these are roughly positive. So to find our R value, we're going to go to Stat, and we're going to go to Calc, and we're going to go to this one right here that says ln reg A plus BX. Okay, and we're going to leave this L1 and L2. And if we want to store it in Y1, we can. So if you go vars, yvars, choose function, choose Y1, that'll put the regression equation into our Y equals for us and hit calculate. Okay, and here you'll see this menu, and here we have our R. So we're going to round just to 2 or 3 decimal places. So here we'd have 0.758. Now, to tell if this is statistically linear correlation, we're going to, for this problem, use alpha as 0.05. That would be given in the problem for you. And the n we're going to go down to is how many there are here. So since there are 9, our n is 9. And we're going to 0.05, so 0.666 would be our threshold value. So we're comparing what we got from the calculator, that's our R, to the critical value here. So R is greater, 0.758 is greater than 0.666. So we could conclude that there is linear correlation.